and I'm one of the admissions officers here at NYC Data Science Academy, and I would like to welcome all of you for today's webinar. You're here because you are interested in learning how to excel as a data scientist in any company, and we have the pleasure to have today one of our alumni, Katie Putelli. But before we start, I will share a couple of important messages, and one of them is we want you to participate on today's event, and you will be able to ask questions. But in order to make sure that we see your question and maybe your question is the same as other attendees, let's all go on your chat box and check mark all panelists and attendees. That's the best way for you to share your question with Katie, with us, and also allow other attendees to see the question because you guys may have the same question. So let's test it out. Let's see if you guys pay attention to what I just said. I want to know, where are you guys logged in from? So just send on the chat box your location. I'll read some of the locations here. Florida, Montreal, New York City. Oh no, Brazil. Yay, I'm Brazilian, by the way. London, England, you guys are awesome. Awesome. Tennessee, Jersey City. Awesome. I really like Jersey City. Yes, you guys are great. You're doing great. Awesome. And then also I want to just chat a little bit now that you guys are all set about our school, NYC Data Science Academy. And we are a data science school. That's all we do, data science only. And one of the features of our school and what we're popular for is our data science bootcamps and courses. Only bootcamp teaching both Python and R. If you are a data scientist enthusiast, you know how important these coding languages are to do the work. We're teaching both, and all the students get lots of hands-on learning, hands-on projects, and you're gonna, with our boot camps, you work with 4 projects, and one being a capstone project, a real project from a real company. Job placement support for all our bootcamp students. We've had over 2,000 alumni, and they are now working in the industry. And well, we are rated the best data science bootcamp and best online data science bootcamp by switchup.org. So it cannot get any better than this. And if your guys are here also, you may be interested in joining the bootcamp. You may be researching. One of the reasons why you guys are here. As an admissions officer, it's my area of expertise, talking about the admissions process, and which is very simple. We encourage every student that is interested in becoming a data scientist to, contact admissions and submit your application. Let an admissions officer, let our team really understand your education and professional background. That's the first step. Are you interested in joining the program? Are you interested in becoming a data scientist? Go on our website and submit your application. Let us help you. And by helping you, we need to know where you're working, your professional experience, so that we do through the application. And then the second step is an interview. We want to talk to you. We want to get to know you a little bit more. So the interview you schedule after submitting your application, and then followed by a technical assessment. So the technical assessment, you working on it, show your technical skills, and we're able to provide you guidance. And and that's the process of admissions in order to become a student. Now, if you are planning to become a student soon, I'm glad to say that we have a session starting Monday, November 9th. This is for our full-time online bootcamp and for our part-time online bootcamp. And if you are planning to start in November, I highly encourage you to submit your application by tomorrow night, because our deadline for the November start ends tomorrow. Okay, for our remote live bootcamp, which starts in January, you still have a little bit of time, but we highly encourage all the students to apply early. This helps not only you to prep for the first day of class, that help us also to guide you through the process. It's always better than leave for the last minute. So yeah, and this is the message that I wanted to do in the beginning. I know I don't want to take you guys any longer. You're all excited, so I will introduce you to Katie.
Hi, everyone. So can I jump in from there? Is it all right if I start sharing my screen?
Yes.
Wonderful. Okay. Thank you. Just one moment. All right. So I just wanted to introduce myself really quickly. Can everyone see my screen from here? Let's see. Chat. Awesome. Good to confirm. All right. So it's really nice to meet you all. As the presenters have mentioned, I was a student about 3 years ago, and I can honestly say that the NYC-DSA Bootcamp was the best professional decision I've made so far in my career. And it was also a really, really great personal decision for me for a lot of reasons. The first being that it allowed me to just understand problems that were being asked in different fields, read the news, and have a better grasp of the statistics and questions being asked. I found I was able to ask more informed questions in pretty much any interview I went into. And since leaving the academy, I had the experience of working for a very large bank for about 2 years. And then after that, in my current role in a startup in the Bay Area. And I just want to give one disclaimer. I'm not speaking on behalf of either of those institutions. I'm talking purely as a data science alumna. But what I wanted to offer you guys today is a sense of what you can do after the boot camp. And I think one of the biggest things a lot of students run into once they complete the boot camp is a sense of, okay, I have all of these skills. How do I find a role that I'm really going to be excited about and where I'm really going to shine? And that's the question I'm trying to answer today, is how do you take all the knowledge that you would get from this boot camp and hit the ground running? So just to define the presentation a bit more, I've worked in a large bank and small startup, and one of the key things I've learned is that the role of a data scientist changes dramatically based on where you are. So what I'm going to talk about today is some of the different situations you may encounter and how to set yourself up for success after you leave the academy and basically go into any profession. So I'm going to be talking about things like defining your job search, the role that you might have in a big bank versus a startup, some of the commonalities, which is under what I learned in a nutshell. And then I'm going to talk a little bit about health and some final takeaways towards the end. But to introduce myself a little bit more, again, my name is Katie. I got to NYC DSA from a bachelor's in neuroscience. I had actually come out of college and thought I wanted to be a neuroscience researcher. So I spent a ton of energy working in laboratories and pursuing a research career until I got to a point where I realized I didn't enjoy research. I didn't want to spend any more time in consulting. And what I really wanted was a skill that would allow me to ask and answer important questions and that I could use in any field. And so that's what eventually brought me to NYC Data Science Academy. The first position that I did land out of the Data Science Academy was working in anti-money laundering at Deutsche Bank. So that's basically anti-financial crime and trying to find patterns of risks in financial data. So something totally outside my previous field. I took a short break to heal arthritis related to Lyme disease, which is why I brought health into the end of the presentation, as you'll see. And currently I'm in San Francisco and I work as a data scientist and product manager at a mental health startup called Total Brain. So that brought me back full circle to the field that I really, really enjoy, except I feel like I can engage with it in a way that's much more interesting to me, that's much more high level, and that gives me a lot more flexibility and freedom. So jumping in from here. The first thing I want to talk about is defining your job search. And this is one of the first things that you'll encounter once you graduate a place like NYC Data Science Academy. And the question is, okay, I have this information. How do I go about finding a job? And I actually received great advice from my brother on this exact topic, where he said to me, treat it like a relationship. No matter how much you want a job, no matter how much you need money to pay rent, keep your standards and try to know exactly what you want and move forward confidently with that goal in mind. So don't become desperate. And some of the questions that I had to start asking myself, first off, were, would I succeed better in a startup or a large company? And that's a pretty fundamental question because those are very different data science roles. So do you want to work in a place with very few resources like a startup where a lot of things are being defined from scratch? Or do you want to deal with a large company where you may be able to get a lot more mentorship and support, but you'll have to deal with a lot more inertia? What size company do I want to work at? It's a related question. And a big one here is, what part of the data science lifecycle do I want to spend most of my time working on? One of the things that if you end up taking the boot camp, you'll realize very quickly is that data science is a single term for a very, very big field, which includes everything from ingesting data and pulling it in from different sources, whether that's spreadsheets or PDF documents or conversations with other people, maybe audio data. So pulling in that data, cleaning that data, creating features out of that data, which is what you actually work with as a data scientist, and then modeling it and turning it into something. There are also different roles based on the scale of the data you're working with. So are you someone who's trying to take information from 200 rows, or are you working with terabytes of data? So there are a lot of questions in terms of what you enjoy doing and where you find that you have the most skill. Another question is, do I see a societal problem that I know a clever way to fix? For me, I actually intended to get into agriculture initially leaving the academy. And so I started studying, okay, how do farms and how do companies define a successful output of crops? What do we know about nutrient output? What data are drones currently collecting in the field or farmers collecting? So that was something that I really dug into. And then, do I want to be purely a data scientist, or do I want to be highly involved with business and some sort of collaboration, which is what I've ended up in my current role? And the most important question probably is, what does it take for me personally to feel satisfaction? So do I need to see the immediate effects of my work? Do I need a great mentor? Or do I really want to be making $200,000 a year or more and I don't care about the other details? And once you've gotten some of those things down, you'll find that it becomes a lot easier to find a job because you can reach out on AngelList, for example, if you know that you want to end up at a startup. You can find recruiters at LinkedIn for large companies that actively are seeking out data scientists and building their teams. You can network much, much more effectively and know what terms to search. For example, if you want to be involved in the ETL part of data science, it's much easier to find other people on LinkedIn who have experience in those roles and can give you some guidance. So that's what I would say first about the jumping off point. From there, I want to talk about what it's actually like to be a data scientist in different environments. And the first one I wanted to touch on is working in a big bank, because this was my experience for almost 2 years. And I would call that data scientist as integrator. In my general experience, and again, this isn't specific to where I worked, and I'm not speaking on their behalf, but part of the job ended up being working directly with the business, and part of it ended up being innovation. And when it comes to working in a large company, you have to find good ways to collaborate with the business people who are already there and communicate in the cases that they've often never worked with a data scientist before. So what you'll end up doing if you're working in something like financial risk management is interviewing a lot of people and understanding what are your current processes, how do researchers currently define risk, and getting a sense of the existing flow of information. Going over to the left side here, the business side, what I spent a lot of my time doing was talking with the business people and researchers and learning how they manually carried out this process. And then I collected the data that they used and started iteratively building models and seeing if I could replicate or do better than the existing work. I also included search for new typologies because working in financial crime, you build off what are the relevant risk factors. And so part of my job was to do research and find, are there any that we're not capturing and that could be built into financial models? When I put think like a business person, that really means what do you need to know and how will it impact the business, and be very, very realistic and clear on what your models can and can't do. So, for example, I learned very quickly that, first of all, I didn't need a hyper advanced neural network model or something very sophisticated. I just needed maybe a simple regression based model. And I also learned to be clear with the business people that AI is not what they've seen in movies. You don't just throw a question at it and IBM Watson answers it. You have to build a very, very specific model to the question that you're trying to address. And if you try to extend it beyond that, it often won't be valid. In terms of innovation projects, I also spent a lot of time talking with other employees in the company and learning what takes up most of your time. Is there any processes I could automate? Where are all the company resources going? Because one of the things I found is that in large companies, information is often siloed. People don't communicate with one another. And so as a data scientist, if you want to be effective, you have to help ease some of those pain points and learn, okay, where can I automate something? How can I maybe make a dashboard that helps one department communicate what they're doing to another? So I spent a lot more time than I had initially planned just interviewing people and learning what do you do on a day-to-day basis, and is there any way that I can help you do so more effectively and to integrate with the rest of the company? And some of the most important things I learned in that were always test your work with the least technical business people in the company, because if you come in as the data scientist or the statistician and no one understands what you're doing, it's very hard to be useful to other people. And the other is invest in learning how information flows within the company, because oftentimes in a large company, there are many, many legacy systems in place, and a lot of data is trapped in silos or areas where you can't get direct access to it. So learn how information is moving, and if there's any information that's maybe been lost because someone's left the company or because it's just stuck in a file somewhere and not accessible to people. Final point, make sure your solution is robust. So if you're building an automation model, create something that's going to work and function even if you've left the company. So leave good documentation, keep good track of your code, and make something that's as efficient and well-written as possible. Some examples of data questions that I found myself asking all the time are, what legacy systems are in place and what are their strengths and limitations? How does data move here? What are the very slowest processes? Do those working around me understand what I do? And who can help me implement changes in this environment? So I want to speak to just a few points here. When it comes to what are the slowest processes in place, I found that this is a hugely valuable question to ask in a large company, because often if you ask an employee, where does the vast majority of your time go, it won't be towards doing their job. It may be towards clicking a series of buttons over and over again, or it may be that they're collecting information and doing something by trial and error. So learn what's working slowly, and try to fix that low-hanging fruit, because if you're able to do that, then you'll win so many points at the company, and you'll free up a lot of other people to do their jobs better. And when I put down who can help me implement changes in this environment, that one's also huge at many large companies, because they often have a hierarchical structure that makes it difficult to find out who's the decision maker and who can help me put this into production. So find the engineers and architects who are going to be able to help you take your models and actually bring them into the company so they can have a wider effect, and learn that as early on as possible. And I gave the example of a negative news scraper. So one of my big research projects at my last job involved interviewing our researchers and finding, where do you spend most of your time? And what I learned pretty quickly is that most of them spend a lot of time collecting and curating negative news information. So I eventually ended up creating an automated project that went in, collected the negative news for them, filtered it, and curated it. And this was something that they didn't know they needed until we started to put it in place and make it available to them. So that's just one example that of a simple fix from my end that helped a lot of people, or was very promising to their team in terms of getting what they needed done. I'll come back to case studies a bit later, but I'm going to leave these in the presentation for anyone who's particularly interested in the area of anti-financial crime, or AML. And I wanted to talk about a totally different case, the startup that I work in now. And in a startup, I've learned data science totally leads the way, and it's absolutely key to whatever a startup is trying to achieve. And if any of you have worked in a startup, you know that it tends to be a very scrappy environment that's still defining its processes and figuring out, what direction to even go in, what's important to our customers. So I put data science at the center here and tried to show how it interacts with teams as diverse as design, engineering, customer success, and product. Starting from my own perspective, I'm currently a product manager and data scientist, and I found that that's a really good marriage of roles, because as a product manager, you're bringing in new features, you're altering whatever the base product is, and it's very helpful to be able to have a hypothesis like, I would like to bring in this feature because I believe it'll increase user engagement by X%, or it will make our product stickier, and to be able to prove that with data. So in my role, for example, I spend a lot of time creating hypotheses, making sure that we have event tracking in place to answer those questions. And then once we launch something, having dashboards that allow me to see if my hypotheses were correct. So it's a completely iterative process that I move forward with. And that's something that everyone else on the team is doing as well, is using data, not necessarily to drive their decisions, but to inform their decisions and sort of keep our direction the way that it needs to be. From the engineering end, there's a lot of interaction as well. And you ask things like, okay, what's the best way to organize our data in a database? Should it all be in a data warehouse? Who's in charge of maintaining and updating the data, which is a huge question when you're a very small organization and you're still figuring out processes. Customer success and sales is an interesting case because there's a two-way flow of data. And as the data scientist, you're sharing with customer success, look, this is how engaged our users are. This is how much they like this new feature. And maybe information like, we see that their stress levels are decreasing because of it. So that's something that they're able to take to our clients to prove the efficacy of what we're doing. And then they offer the data science team verbal feedback as well, in the form of, the client would like to see this change added. This is what they've noticed while doing the registration flow that they don't like and would like to see fixed. So there's a two-way flow of data there. And then in terms of design, this is also a pretty key relationship, because like product, design builds on hypotheses of how they think users are interacting with our product. And data is really the way if we confirm or deny that what we know is true. So that has a huge influence on the aesthetics of what we're doing. And startups use everything from like user testing websites to A/B testing, to just event tracking dashboards to make sure we're headed in the right direction. Some of the main questions that you have as a startup are things like, what are our KPIs, and do we even have the data to measure them? So for those familiar with Google Analytics, tools like that are very important, so that you can see user activity through events on your website or app? Are there ways we can share data more smoothly between teams and really get it all in one place? How can we make data accessible to as many people as possible within legal limits? I would say this question is going to get more and more important as more data protection laws are put into place. So more tools, more BI tools are going to become common, and companies will have to decide who within the organization is going to actually be able to touch the data and who is going to just see it represented visually. What user experience are we trying to create? Does the data suggest we're succeeding? And I would also add, how can I document and structure this process? Because in a growing startup, there's a huge turnover of people and team structure is very fluid. So to have something put into a document where others can easily see it and follow it is a very important way to go about things. And to give one everyday example of these problems at work, in our current company, one of our big things is creating neuroscience informed games. And so one of the things that we often do is we'll put a game out there and we'll attach tracking to it so we can see how far are users getting in the game, at what point are they closing it out. And we've used that to refine a number of our games, and we've discovered that in some cases, users really aren't clear on the instructions, or they don't understand the goal of the game at the outset. So that's led us to actually revise a lot of the instructions and write the goals of the games up front. But we spend a lot of time observing what we could see of user behavior and time spent in certain games to see which ones users were just getting confused by and leaving before they even got very far into it. Again, I'm going to leave the case study here, but we'll not touch on this at this exact point and may come back to it. In terms of large companies versus startups, I broke it down into a few different sections so you can get a sense of it. But to give you a basic idea, at a large company, you'll often work as a pure data scientist, which means you'll have a mentor, you'll often have a lot of financial support and resources. And the only downside of that is you'll tend to get siloed. Whereas at a small company, you won't just be a data scientist, but you'll often have to think at times like a product manager, designer, engineer, and QA person at the end of the day. And you'll be expected to understand the needs and desires of the other teams as well. In terms of assignments, in a large company, you may get the chance to work on something really, really well developed. So maybe if you're in fintech, you'd be doing highly advanced modeling in terms of neural networks or something along those lines. Or you may be in an industry that's just ready to start being disrupted. And that would be something like construction or shipping and trade. And the best way to figure that out is to either talk to a contact in that industry and ask what's automated and what's being done on paper, or you can look at the news and see what the main problems in that industry are, which is one of the ways that some friends and I found out that in terms of shipping and trade, there's a lot of room for disruption there. In a small company, assignments vary significantly. On some days, I'll be doing something that's high-level data science, and on other days, I'll be asking really basic questions like, do we even have data in a good, solid database at the moment? And is everyone who needs to see it able to see it? In terms of infrastructure, at a large company, you'll have legacy systems and databases that are well established by the time you get there. And right off the bat, you'll need to start learning, how does this system work and how can I adapt myself to it? Whereas at a startup, you'll often have a say in the type of structures that are in place. So you'll have the chance to shape some of the flow of information within the company. And oftentimes you'll be able to help define how the company collects and uses data. So for example, working in a startup, I've had to learn much more about APIs, databases like Elasticsearch and Dynamo, their pros and cons. So for a small company, I would highly recommend digging in a bit to architecture and engineering to understand those details that those details that impact how data is going to be available. And you'll be partially responsible for making some of those decisions, most likely. Finally, I would chalk it up to, at a large company, it's a great environment if you value stability, you want more resources, and there's a brand or proven company that you really, really want to work for. In those cases, you're in the right environment and you can count on a lot more mentorship and similar day-to-day activities. Whereas as a startup, it's fantastic if you want autonomy and flexibility to try new things. It's really a great way to learn a little bit about every role at once because it forces you into so much interaction with other teams. But it does entail a lot of chaos. So you might spend one day doing data science and you might spend another day just talking to other teams or trying to figure out why a database has gone down and you're not able to do anything at that moment. So you can't predict the day-to-day as much, but you'll most likely learn a wider variety of things that you didn't even know were part of a data science job. To focus on some of the commonalities that I found in pretty much all work environments and that friends have echoed me on, I would say coming out of the Data Science Academy, you'll have a lot of knowledge and a lot of advanced skills, but in an actual work environment, the key thing to keep in mind is focus on the business problem and the low-hanging fruit and don't focus on complex solutions. So for example, in my previous job, I met a lot of interviewees who wanted to say, let's throw a neural network at this. I know I read a math textbook. I know a very advanced solution, but they didn't realize that what we wanted was someone who was interested in our particular business problems and the easiest, clearest way to handle it. So focus on what's low hanging and what's simple rather than what's advanced and impressive. Because oftentimes in a company, no one around you will be able to understand you if you put in a highly complex solution. You want something that you're going to be able to explain to other people, and that if it goes wrong, you yourself will understand why it's likely not working. So focus on the problem rather than the technique. Secondly, ask other employees about their pain points and watch what they spend most of their time doing. One thing I've found in pretty much any work environment is that other employees may not even know their immediate pain points, but as a data scientist, if you watch them go about their work, you'll see things that can be automated or things where maybe you can help them bring in more data to create a decision that would give them better results than they originally had. Look for siloed sources of information that can add to or give context to your data. And that's everything from look for documents that are currently in paper form to talk to individuals who may have historical data and who are about to leave the company. And finally, grow beyond your role, because when I left the academy 3 years ago, a data scientist meant one thing, but nowadays it's changed so much that you become obsolete each year if you don't continue to retrain yourself. So you have to get interested in databases and their limitations, APIs and network architecture, event tracking and tools like Google Analytics, and more importantly, get very interested in your customers and their concerns. Oftentimes a data scientist is depicted as a backroom person who just focuses on the models and the techniques. But one thing that's become very clear in the environments I've worked in is that the best data scientists are the ones who talk to people and who know what problems are most relevant and what questions aren't being asked. So it's very hard to advance if you don't get outside of the computer. And on that same note, the modeling itself, like running an algorithm, is a very straightforward process, but asking a question and cleaning up the data so that you can prepare to answer that question is a lot more of a sophisticated, nuanced process. And that's more likely where your time will end up being spent. So it's just a small Dilbert cartoon to give you guys a pause here. And this is also just a small example of some of the miscommunications that can happen between management and a technical person. So keep this in mind as one of the downsides of getting too technical in a conversation with a manager, for example. All right, 2 more slides. This one is very, very personal to me, and so I hope it can be helpful to someone out there. As you get into the data science field, there's a lot of initial pressure to spend hours at a time at the computer, go all night on a project, really just work until it's resolved. But I would make the case up front for consider this a marathon rather than a race. And even if you love your job, you're not evolved to spend every single moment or day in front of a computer. So find a balance early and figure out what you need to do for your health and sustainability. And one of the reasons I mentioned that is I ended up with arthritis while working at my first job out of the academy. In my case, it was largely due to Lyme disease, but as I looked around at my other coworkers, I noticed that pretty much all of them ended up with shoulder problems, they were wearing braces, or they had something similar to carpal tunnel. So what I learned from that experience is that you have to get a balance and get outside, expose yourself to natural light, eat to reduce inflammation, which affects all of the conditions that I've just mentioned, and even mental health ones. Don't neglect your posture. One of my coworkers regularly did yoga and Pilates, and I noticed that she felt very healthy on a regular basis. I've also included some movement exercises like somatics and Feldenkrais and Alexander technique that really help keep your body aligned so that as you're working, you don't start to slouch and have neck and arm difficulties. And finally, if you have coworkers who've been hurt, try to get the name of a good physical therapist or acupuncturist or practitioner up front so that even if you don't need them, you have resources in hand in case you need additional health support. The book Pain Free by Pete Egescu was incredibly helpful to me. So that's just one that I would specifically call out. Some final takeaways. Once you've finished a data science academy and you're out in the wild, as I'll put it, there are a few things that you need to keep in mind for the long term. And one is you've just put in an exceptional amount of work, but adaptability is really key. So if you don't continue to learn, a lot of your skill set will be obsolete after a year. I've been asked multiple times if people think that data science will continue to be a hot field. And my answer to that is always yes, absolutely. However, it won't be the data science of 5 years ago. So the great data scientists will be the ones who ask really intelligent questions, who dig into the data and are able to clean and shape it very well, and who are then able to communicate it in a way that's clear and offers insights back to whoever they're working with. So data science is not in any way becoming obsolete, but for any data scientist who's coming out of the academy now, they have to really think, where are my strengths and how can I keep growing myself each and every year? Interest and involvement in every step of the process is key. In my first job, this meant knowing what a Swift message was when it came to wire transfers, asking people what the meaningless data fields meant, because I would be given Excel sheets with 200 columns of data and would have to really ask, what does the rest of that mean? And is there something that other people have overlooked? With regards to the next few, when I was in financial crime, I had to understand what's the history of crime, what are the risks to banks, and what's going on the larger legal political level that's affecting my industry. So basically, I had to go far beyond data science to really get the information and ask the questions that would make me effective at what I was doing. I've also included empathy and insight down here. So I've said this a few different times, but as a data scientist, you have to also consider yourself a business person, an engineer, and a leader, because it'll make you better at your role. A lot of what you do, like I said, in a bank, you're an integrator, and in a startup, you're really in the center of the organization, but you're touching every other role, and you can only really be effective if you understand the needs of those different groups. And finally, don't expect other people to understand the technical aspects of your work. I learned very early on that even showing the results of a simple algorithm in the form of a chart confused a lot of the business people I worked with. Make an effort to be clear and collaborative, because people will really want to work with you, and they'll often get uncomfortable and won't engage with you if they don't feel that they can understand the benefits of your work, or if they feel stupid that they don't understand math. So always make an effort to engage with people in a way that they can understand. And to end on a positive note, have a desire to keep growing, do side projects, and read a lot of blogs. So I've included one here that I used to work with, which is called Pro Bono Analytics. And that's a data science organization that pairs data scientists with nonprofits. It's out of NYU. And to be honest, I'm not sure what their current activity level is, but it was a really great concept of getting people in touch with organizations that couldn't afford to hire a full-time data scientist and helping them get their feet wet. The blog I've included at the bottom is called Automating OSINT, and it's just a fun intelligence blog by someone who goes out and almost solves crime or resolves social issues using data science. But the key here is have fun, because one of the reasons people go to a data science academy is they want new, fresh skills in their life, but also they want to do something they enjoy on a day-to-day basis and have something really engaging that catches their attention again. And that's the part that you have to work hard to not lose, no matter what your day job is like. So keep being interested, look for ways to enjoy it. And really, that's all I have for you at the moment. I'm happy to take questions, but I want to end on a positive note. This is a really interesting field. So keep engaging with it. Find blogs that you enjoy, find resources and documentaries, and reach out to other people and brainstorm cool projects that you can work on together, because this is such a great opportunity that you're at. Let me open up the chat. I'm actually, I finished for now, and I'm happy to go to some of the case studies more specifically, but I couldn't see the chat while I was talking, and so I wanted to come back to it now. Let's see. I'm coming back to these now. A memorable problem you solved as a data scientist. How did you solve it from a technology standpoint? And which team members were instrumental in cross-functional coordination? Very cool. Okay. Terrence, are you all right if I start answering some of these questions?
Yeah, go ahead.
Okay. So I think when it comes to a memorable problem that I solved, I would use the example of working in anti-financial crime, because one of the most interesting problems once I actually got into the field had to do with new methods of crime that were becoming common. And if any of you are familiar with anti-financial or financial crime in general, I'm sure you've heard of shell companies. So these are a challenge for a lot of banks right now, and they're basically companies that appear real in a lot of ways, but they're just front organizations where there's no real company there. Money is just getting siphoned through it, and it's being used for illegal purposes generally, or it's being taken out of illegal purposes and made to seem legitimate. And so my coworker and I got very into that, and we started to look up what are the most common characteristics of shell companies. And so we collected data on some of their addresses, some of their sizes, whether they actually had company websites, whether the amount of money that they were making made sense for the industry they were in. And we put together a pretty good shell determining model, which is something that as far as I know, wasn't really widely being done at the time. And that was a huge data science win for us, just because it was totally new and it reflected a type of crime that banks are still struggling with. In putting that together, we had to talk to a lot of business people as well as researchers. So we talked to the researchers in the bank who analyze risk, and we said, when you look at a company, what do you look at to determine whether or not it's high risk and whether they're conducting shady activity? So we looked at a lot of their reports and we got a sense of their thought process about what makes a place a shady company at the end of the day. So we collected a lot of that information directly from them. And then when it came to other cross-functional coordination, we would test this model out, run it and determine its accuracy, and then bring it back to the researchers and say, hey, it missed these companies. Do you have any other insights you can give us on ways that we could determine that they're shady, any other data we can use? So it was a very iterative process between the data team, business team, and research. And something that ultimately really helped us was learning that network behaviors were very important. So one of the things my coworker found was that rather than looking at rows of data, if we could visualize it as a network graph, it became much clearer when you saw an unusual pattern. For example, if you saw many disparate companies in different industries giving money to one company in a totally unrelated field, that was a huge red flag. So we also had to learn to visualize the data really differently to see some of these trends. And I hope that answers that. Let's see. Yes, my spouse is occupational therapist. Absolutely. I also did consult with an occupational therapist, so I apologize for leaving that out. Those are all really good fields that work together to help you avoid slouching and ending up with neck, back, and arm problems, which I would say about 50% of my coworkers who are in their 40s and 50s ended up with. Let's see. What major things have you seen change in data science in these years, and what kind of issues do you think will have the most demand growth that a data scientist can help solve? So first off the bat, I would say that one of the biggest changes I've seen is that when I was first starting out, a data scientist was someone who created really basic visualizations. And if you could run a random forest model or something fairly fundamental in R or Python, then you were basically a data scientist. So it was a lower barrier to entry. I think the expectations were lower. And I would say over the past few years, the expectations have raised to the point where being able to run models is very, very simple, especially in Python. So that's the bare minimum that's expected. I would say that as a data scientist nowadays, you'll be expected to not only have a fundamental basis in statistics, which the Data Science Academy is really great at providing, but you'll need to know a bit about APIs, databases, and different types of databases. How to put a model into production is really, really key, because that's an area where most companies don't know how to do it. So if you get experience actually bringing your model into production, and meaning getting it running at the company automatically, that's a hugely valuable skill and experience set to have. But one thing I would say is perennially important is knowing how to ask a really good question. So one example I would use is my brother is also in a technical part of advertising, and he told me that most people in advertising focus on clicks. That was the key metric for a long, long time. And he and others are starting to actually say, no, clicks don't matter. It's whether someone completes a process and actually buys something or follows through in the way that you need for them to provide you a financial benefit. So just making sure that you're asking the right questions and collecting the right data points, I think, is really undervalued. That's something that still most people aren't doing. What would you say is the most important skill for a data scientist? How NYC helped you get a job? And did you know programming before starting the bootcamp? I think I've touched on some of the most important skills. For me, honestly, the most important skill is knowing how to ask a good question. Like knowing that your data science skills are connecting to a solid business question and making sure that those two line up. That's really fundamentally important and I think overlooked. When it came to how NYC Data Science Academy helped me get a job, they were fantastic. What they actually did was they went through my resume with me. and helped me clean it up both on paper and on LinkedIn. They gave interview practice, and they gave us a lot of trial interview questions. They gave interview reviews. So if, say, something didn't go well, you could come back and talk about the question that you struggled with. So it was like a really great network to be able to go to when I was searching for a job. And I found a job within a month of my time there. Did I know programming before starting the bootcamp? The most programming knowledge I had was a few months of experience in MATLAB in college, and some really basic Python experience as a researcher. But even without those skills, I would have been absolutely fine at the academy. What does a job interview for a data scientist look like? So a job interview for a data scientist can really vary. I'd say there are two major variations. There's the variation where you're put in front of a whiteboard and you're told to answer, or a virtual whiteboard, and told to answer a very complicated question in a short amount of time. And that's incredibly stressful. I'll say right off the bat, I don't do well in those situations. But that's sometimes the reality. And those just require practice and giving yourself a lot of online prep. The other type is you'll be asked conceptual questions, and a company will just want to know how you think and if you have the potential to grow. And those were most of my interviews. I'd say about 60%. At the two companies I've been at, they see data science as a role where you'll ultimately have to grow a lot. And what they usually look for is someone who's flexible enough in their thinking that they can pivot and gain new skills as need be. Let's see. Can you share the slides? The slides will definitely be shared. Deck will be sent out. For someone new entering the data science job, what would you advise where to look for projects to work on to count as work experience in the resume? That's a great question, because that's a very difficult aspect, is starting to get your feet wet while you're looking for a job. Pro bono analytics, which I mentioned, and similar organizations are great because they'll connect data scientists to people who need that support and who can, give you positive recommendations afterwards. So look up, pro bono organizations or nonprofit organizations that need data scientists, and do a bit of free work if possible, just to test your skills. I would also say go on Kaggle if you just want to see how you're doing compared to other people. And finally, don't be shy about coming up with a problem and seeing if you can solve something yourself. So if you can put together a really basic dashboard or application as a personal passion project, that'll speak volumes to people. And it's very, very impressive if you can put out that work and maybe blog about it on Medium or elsewhere. For your job at the financial firm, did they require financial knowledge? Actually, they made the comment that it would be much easier to teach me finance than to teach me data science. So I went in knowing nothing, practically nothing. And they were very welcoming and willing to help me get up to speed on the finance part. Was the interview process mostly focused on machine learning? The interview process was focused on understanding how I would use tools like machine learning to answer some of their major problems. So for example, I was given a sense of how they were currently doing things, and I was asked to look for issues within that process and how it could be improved upon. I was asked a few basic statistical questions. But when it comes to the interview process, really study a bit of everything because different companies are very idiosyncratic. Let's see. Yes. Is domain knowledge important in finding data science jobs, and are data scientists looking for a particular domain? That's a great question because companies often don't know what they're looking for. Whoever's coming up with a job description often doesn't realize when they write data scientists that what they want is an ETL person to help them pull in and manipulate the data, or that what they want is really a data science engineer or a data engineer. So it's often good to reach out to companies and really understand what am I going to be spending most of my time doing? What other resources and engineers do you have? Because if the answer is none, then you'll be spending a lot of time troubleshooting engineering issues. So that's a good thing to reach out to a company on, because they probably haven't thought about the different nuances of what they'll want you to do. And it's good to know ahead of time, for example, that maybe you'll be spending your time cleaning data when what you'd much rather be doing is modeling. So that's something to be very proactive about. Let's see. Which trainings or resources would you recommend to progress efficiently in the field? So there are there's so many different trainings and resources out there. Personally, I like some of the Coursera classes that are offered by universities like Stanford or Johns Hopkins or U Michigan. But I would also say don't underestimate the power of a place like Medium, because I recently went on there to learn how Plotly Dash works and to learn more about API endpoints. And Medium has been a super helpful resource in terms of just filling in gaps in knowledge and getting some code examples of how to do things. I would also say get very familiar with Stack Overflow and GitHub, and get comfortable just reading the code of people you don't know, because that's going to be one of the fastest ways to technically grow. But those are my top recommendations would be, let's see, Medium, GitHub, Stack Overflow, and if you're interested in continuing with it, Kaggle. Let's see. If attending a bootcamp is difficult to fit into your life, which I can totally understand, do you have any recommendations as to ways to approximate it? I would say this one is difficult because I initially intended to do a flexible arrangement and just do the online boot camp, but I found that there was a huge advantage to really doing it formally and staying on a schedule. So if at all possible, try to, even if you have to do it flexibly in the online experience through an organization like NYC-DSA, find ways to still give presentations on time, like turn in projects on time, and try to hold yourself accountable, just because it's really, really hard to get the same level of knowledge when you aren't talking to teachers directly, or when you're not interacting with other students and seeing how they would solve problems. Because yeah, I've tried to do it on my own, and it's hard to keep up that level of accountability when it's just you. So for the next question, I did end up doing it in person. I know some students did it online, but I found there were a lot of advantages to in-person, both in terms of camaraderie and getting to know the network, and in terms of just accountability and having to show up each day, even when you wanted to sit in bed and try to code from there. Working on a data science project as part of a team. Yeah, I can speak to that a bit. So I would say in the 2 work environments I've been in, I have about 50% flexibility in terms of the projects I work on. Most of the things I'm brought in to do are business necessities, so I don't have a say in terms of those specific problems, but I have a lot of flexibility in terms of how to approach it. So one example would be in my previous job, it was mandatory that I find ways to identify risk, and that I look for the best indicators of risk in models, because that's something I had to present on. But in terms of something like a negative news scraper, that was something where I just talked to different researchers and figured out what are their needs, what are their pain points, and do I have enough bandwidth in my schedule to build out a prototype and start addressing this. When it comes to working as a team, I've only ever worked on very, very small teams with, say, 1 other data scientist and a few engineers. But I would say the best part of that was having other people around for the research process. So we could come up with hypotheses together and really figure out, is this going to be feasible from an engineering standpoint? Will this be useful to other parts of the team? Is there someone else who has knowledge in this area? And that's been really fun at both companies. It's hard to describe it in a nutshell, but as the data scientist, for 50% of the project, you're really an interviewer and a researcher trying to figure out what resources do we have? Are we asking the right questions? And who else would be interested in this that perhaps we haven't thought of? And the actually cleaning the data and running it part and iterating on it that part is more individual. And that's the more bread and butter data science work. Let's see, we're able to pick your projects, decide how to approach a problem. And yes, finally, you do have a lot of flexibility in terms of how to approach a problem. And that's the really creative, fun part of doing this type of work. I'm starting to lose my voice from talking at full speed. I hope this has worked for you guys. I apologize. Usually I can hear some feedback if I'm presenting to people. And so I'm sorry for talking straight at you, but I really hope it's been helpful. Thank you so much. And yeah, I'll stop sharing my screen in just a moment, but if any of you have further questions, feel free to reach out to me on LinkedIn, and I'm happy to discuss anything personally, especially if you're interested in neuroscience or anti-financial crime. And thank you guys so much.
Thank you so much, Katie, and thank you all for being with us today. I hope you guys have a great time and learn a lot. Again, if you guys are curious and want to learn more about the bootcamp, reach out to us, speak with one of the admissions officers. We are here available Monday through Fridays from 9 a.m. to 6 p.m., answering all your questions. And don't forget, if you want to start in November, our session in November, you should submit your application by tomorrow night. I hope you guys have a great night, and I'll see you in the next webinar. Take care, everybody. Bye.
Thank you.